Hello, Algebra 1 class. So this is our second video in writing linear equations. We're going to do a whole bunch of different examples, some with lines of best fit, some with graphs, and looking at both using slope-intercept form of a line as well as point-slope form of a line. So take a look at this first example. Garibaldi sells candy at the football games. He initially had 300 boxes of candy. Every minute he sells 4 boxes. So he's losing boxes of candy every minute, or he's selling them, and his number of 300 is going to go down. And the amount of candy which Garibaldi has is a function of time. So the first thing we want to talk about, is it increasing or decreasing? Since he's selling 4 boxes every minute, it's decreasing. All right, what is the rate of change or slope for the function? That's how much is the number of boxes changing by. And clearly in this one, it just tells you it's 4 boxes. But because it's decreasing, we write the slope as -4 boxes per 1 minute. You really don't need to write the per 1 minute. And the y-intercept is where he started. Where was he at 0 minutes? And that's where he initially had 300 boxes. So we'll call that B, and this one M. All right, so now we can write the equation pretty easily. So first of all, let's assign our variables. Y equals number of boxes of candy, and X equals number of minutes of time. All right, so the number of boxes of candy equals the slope times the number of minutes plus the y-intercept. Or you could think about it, he starts with 300 and every minute he sells 4 boxes. Those are the same things. And then it says, how long will it take Garibaldi to sell all of the candy boxes? Show your work. These are really why you write a linear equation or a linear model, is then you can use it to answer future questions. So for him to sell all of his candy boxes, that means he's going to have his y equal to 0. No candy boxes left. So we just plug that in and solve. 0 equals -4x plus 300. I think I'll add the 4x to the other side or to both sides, and you get 4x equals 300. Divide 300 by 4, and you end up with x equals 75. Now remember, x is the number of minutes, so that's 75 minutes, or 1 hour and 15 minutes is how long it takes. All right, so that was an example of slope-intercept form. All right, so here's more examples. Now this, they're not giving you a word problem, so to speak, but giving you a table of data points. And you could plot these, and then you have a graph, and you can write your equation of a line. I wouldn't call this scatter plot, in that these are either going to be linear or they're not. So the first one, the table below shows the cost of renting a canoe for different time amounts in hours. Can this situation be modeled by a linear equation? If so, write an equation that gives the cost as a function of time. So cost is your y as a function of x. Time is your x. So what I do to see if it's linear is I look at my change in x and I look at my change in y, or the difference, and I see if those are constant. So looks like here in my x I'm going 2, 4, 6, 8, 10. That means it's all a constant plus 2. And then I want to see if this is a constant change too. And look, we go 22 to 32, that's plus 10, plus 10, plus 10, plus 10. So that's a plus 10. So when I look at my change in y over my change in x, my slope is 10 over 2, or 5. If I have a constant change, like I have in this case, it can be modeled by a linear equation. So the first answer is yes, emphatic yes. Now I can write my equation. I'm going to use slope-intercept form. Y cost equals my slope times time, and I need my y-intercept. Well, the y-intercept is when time is 0. So one of the tricks I do is, do you notice that that's going backwards, right? Down to where this was up to, and for every up to, it went up 10. So that means to go back 2, I'm going to go down 10. So that would be a 12 plus 12. And because I was doing that, I think I better check my work. I'm just going to make sure that if I plug in any of these x's, I get the y out. So let's plug in 8. So y equals 5 times 8 plus 12 equals 40 plus 12, and that's 52. Bingo. Input of 8 gives you 52. I know I did a good job. All right, next one. Can the data about mailing costs in the table below be modeled by a linear equation? So if it can, write an equation that gives cost in dollars as a function. Oh, typo again. Yuck, sorry guys. Cost in dollars, so that's my y, as a function of weight. That's my x. All right. So I'm going to do the same thing I did on the first table and see if there's a constant change. And let's see. We go plus 3, plus 1, oh dear, plus 5, plus 2. Well, that's kind of a problem. I can't just quickly say, all right, from this point to that point, it's a nice constant change. But let's look here. So from here to here, it's 0.69 or 69 cents. Here it's 23 cents. Here it's $1.15. And here it's 46. Well, I'm not going to give up yet. It doesn't mean it's not linear. The problem here is I don't have a constant change in x. But if my y is a function of my x, in that for every change in y, I get the same ratio, I'm in good shape. So what I'm going to do is I see this one here. Let me change my color real quick. And I see this is a change of 1 and it's 23 cents. So if I have a slope, it's going to be 0.23. So if it's linear, my slope is going to be 0.23 divided by 1. Well, let's just check and see that if I did my change in y of 1.15 divided by 5, do I get 0.232? And guess what? Take out your calculator. You do. All right, let's do it again. 0.46, this was a plus 2, divided by 2. Look at that, 0.23. So it looks like, let's check this one. So this was 0.69 divided by 3. That's 0.23. So it is a constant change. So my slope is 0.23. All right, yes, it's linear. Yes. Yay. All right, but now I have to write the equation. So once again, y equals 0.23x, that's my slope, and I need my y-intercept. Well, here's 1, I'm going to go back to 0. So 0, I have to subtract 0.23, so 0.37 minus 0.23 is 0.14. So 0.14. So mailing costs, it's 14 cents. And then every ounce is another 23 cents. And that's your equation. And of course, you can check it by picking any point and making sure it works out. Good. All right, this next example is a great point slope example. So let's look at the problem. A camp charges a registration fee and a daily amount. The total bill for one camper was $338 for 12 days. And the total bill for another camper was $506 for 19 days. How much will the bill be for the camper who enrolls for 30 days? Well, to answer the second question, I think I'm going to need a linear equation, or hopefully this is linear. And since there's a registration, like a one-time fee and a per day fee, that's like, a linear equation kind of situation. So it says identify 2 data points and then write the linear equation. So x is going to be the number of days, and y is going to be the total cost. And great, I'm going to write these as ordered pairs. We have 12 days is $338, and 19 days is $506. So they gave me 2 points. All right. Let's plot these. I think I'll do every box is 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. All right, that should cover us. And for costs, maybe I'll go up by 100. Let's see, 100, 200, 300, 400, 500, 600. So 12 days, that's right here, is 338. So 1, 2, 3, about right there. And then 19 days, which is right there, and that's $500. 1, 2, 3, 4, 5. So we have these 2 points. And if we expect it to be linear, then that continues. You can kind of see there might be a y-intercept down here. That would get us our registration fee, and our daily amount is going to be our slope. All right, let's write the equation. So first thing I have to do is find my slope. y2 minus y1 over x2 minus x1. I chose the bigger point to subtract the smaller point, so I'd say positive. So we end up with 168 over 19 minus 12 is 7, which, take out your calculator, is 24. My slope is 24. Slope is the daily amount. Okay, I've got that. Now I've got to write my equation and hopefully find my y-intercept. So I'm going to use point-slope form. I can use either point. Let's see. I'm going to use the second point. Y minus y equals slope times x minus x. And let's distribute. And we end up with minus 456. That's 19 times 24. And we're going to add the 506. And bingo, our equation is y equals 24x plus 50. All right, that means our registration fee is $50. That actually looks pretty good. I go back to my graph and I check it out. All right, now we can answer the question. What will be the bill for a camper who enrolls for 30 days? So all I have to do is let x be 30. So y equals 24 times 30 plus 50. And you end up with y equals 720 plus 50, which is $770. And that's that. And if we continued out to 30, it should be up here at 700 sometime. All right, this example, we have two scatter plots, if you will, or data plots. One is the income of registered nurses over a number of hours, and the other is the income for an architectural drafter over a number of hours. So this is the total income divided by, or for a number of hours, and they plotted those points. So I'm going to start with the nurse and write an equation to represent the hourly wages. So first of all, I can see that my y-intercept in both of them is 0, which makes it easier. Now we have y equals mx plus 0. So all I need to do is find the slope. So the slope, I just need to take 2 points. So let's see here. I see this point here. That's pretty good. And I also see this point. Which point do I see? Let's see. This point here. There we go. I'm going to use those two. They're nice little intersections. So this one is 6, 200. This one is 9, 300. All right, so my slope is y minus y over x minus x, which is 100 over 3, which is 33.3, repeating. That's dollars. That's how much a nurse makes per hour. So y equals 33.3x. All right, now we got to do the architectural drafter. And here I'm going to find some points as well. Let's see, I'll use this one and this one. Those two are right on. Actually, they got all their points right on. So this is the point 6, 150. And the point 7, this one here, is 7, and it's in between, so 175. All right, so our slope equals 175 minus 150 over 7 minus 6. That's $25 an hour. So their equation is y equals 25x. All right, so that was a lot easier because the intercept was at 0, 0. It would be harder if it was not at 0, 0, and then we'd have to take a point and the slope and use point slope form. Okay, we just have 2 more examples, this one and another one. Both of these, we can draw a graph if we want, but I'm going to focus in on the information. The total receipts for motion picture theaters were $3.9 billion for 1986, $6.9 billion for 1992. Hey, look, I'm given 2 ordered pairs. That's the way I look at that. Write an equation to model the relationship between receipts and time. So receipts is your y. This is receipts. And time is your x. So years. Year. And they say let 86 correspond to 1986. So let's write down these as ordered pairs. We have the ordered pair 86 3.9. So this is in billions. And then we have the point 92, 6.9. So I'm going to use that to find my slope. M equals 6.9 minus 3.9 over 92 minus 86. I end up with a 3 over a 6, which is 1/2. All right, you know what? We didn't even plot this yet. Let's go ahead and plot this. So this is years. I'm going to do a little scale break. This is harder for when you need to look at the y-intercept, but it'll be easier. I'm going to make this 80, just kind of even number. And then we've got 2, 4, 6. Here's 86, 88, 90, 92. Okay, so there's our x-axis. And then our y-axis, we've got pretty low numbers. I think I can start at 0, and I'll just make these each a billion. So that's 1, 2, 3, 4. So 86 right here. 82, 4, 6. Up at almost 4 billion. And then 4, 5, 6, 7. So 92 is up almost at 7, 6.9 billion. So you can see, kind of with the scale break, there is our equation of our line, our graph of our line. So our equation, we're going to use point slope form on this one. Let's move it up. So I have my slope, which is great, but I'm going to pick which point. Let's see. I chose this one. So y minus 3.9 equals 1/2 times x minus 86. All right. So we're going to distribute y minus 3.9 equals 1/2 x minus 43. Add the 3.9. We end up with y equals 1/2 x minus, you got to do minus 43 plus 3.9, so minus 39.1. There is their equation. And then it says, use your equation to predict motion picture receipts in the year 2010. Well, think about this. If 86 is 1986, this is 110. So, right, because we're subtracting 1900 from that. So we want to plug in an x of 110. So y equals 1/2 times 110 minus 39.1, which is 55 minus 39.1. And our receipts in the year 2010 will be 15.9. And remember, this is in billions. So some of the hard part about using time, if you pick your x value starting, you've got to understand what your x represents. But that makes a lot of sense if you had, let's see, 3.9 billion in 86, 6.9 billion in 92, that means in 2010 it went up pretty quick, and you're at 15.9 billion. Okay, last example. All right, let's look at our last example. Here we have worldwide carbon monoxide emissions are decreasing about 2.6 million metric tons each year. So actually, they're telling us it's a decreasing function. And how much per year? That will be important. In 1991, carbon emissions were 79 million metric tons. So they're giving us a point. We need to use a linear equation to model the relationship between carbon monoxide emissions and time. Let x, so they're saying let time be the x-axis, and they're saying 91 corresponds to 1991. So this is x, and this is year, and that means this is y, and this is your emissions. Okay. And we have our slope. It's coming down, so it's negative 2.6, so this is in millions. Sorry about my writing. And it's coming down 2.6 million metric tons per year. All right. We're also given the point 91 is 79. So it's not our y-intercept, but it is a starting point, if you will. So I am going to plot what we have. Let's see. So year, why don't we do a scale break and start this at 90? So there's 91. Let's just mark 1, 2, 3, 4, 5. And this is the year 2000. So I'm going to call this 0, 0. Okay, so now here on the emissions, we got to get up to 79, but we know it's coming down. So I think we'll do 10. So 10,000 or 10 million, 20, 30, 40, 50, 60, 70, 80. This is 80. So in 91, we're up here at 79. And we know it's coming down 2.6 million per year. So, all right, we can plot this again in a minute. Or we could also say, 2.6 times 10 and find out kind of where this point would be. But let's go ahead and use let's use point slope form to write the equation of our line. So we have a point and we have slope. So y minus 79 equals slope times x minus 91. And there we go. We're going to distribute and get y minus 79 equals negative 2.6x plus 236.6. And we're going to add the 79, and we get our equation, y equals negative 2.6x. Don't forget, x represents the year from 1900. And then we have plus 315.6. All right, so that is our equation. So just so you know, this is a pretty steep line, because if this is 80, our y-intercept is way off this graph. Way off this graph. One thing we can do, though, is let's get the point at the year 2000. So the year 2000, 2000 minus 1900 is x equals 100. I'm going to go to a new color. They didn't ask for this, but usually it's helpful to have another point. So, okay, so if x equals 100, so year 2000, which is 2000 minus 1900 gets you 100. We plug that in. Y equals negative 2.6 times 100 plus 315.6. Y equals negative 260 plus 315.6, which when you go through that calculation, you end up with 55.6 million metric tons of carbon monoxide emissions in the year 2000. So I'm going to add that point. So here's the year 2000. And if remember, these were tens, 10, 20, 30, 40, 50, 50, 60. So this is 55 over here at the year 2000. Okay, and we can see our linear equation. Now, note, this looks like it's crossing right there, but remember this scale break. Always keep that in mind. Really, 0 is way off the screen, and that means if you continued this up, you can see where it would get all the way up there at 315. All right, that was the last example, kind of a whole bunch of different kinds of things. Hopefully you already started in on your homework, which was more focused on just basic point slope form, but I wanted you to see examples with graphing and with scatter plots, because you will need that as we go forward with our line of best fit work.